Hey, I'm Connor, and I'll be going through the final project for Fluid Mechanic 1. Let's just hop right in, open up a Fluent, name it whatever you want, and open up a, well, first make it 2D, and open up a new design modeler. All right, now that design modeler is open, go ahead and hit the XY plane, and let's just go straight into a sketch. I start my wind tunnel from the origin. Some people have the middle of the wind tunnel, the origin. It really doesn't matter, but that's just how I prefer to do it. So I'm going to start with 3 horizontal lines. The length don't matter. We're going to put that ourselves. So the first length is 1.76. Hit that one more time. 1.1176. There we go. And then the text section 2112. And then the diffuser. And then just go ahead and make 4 parallel line or vertical lines that are parallel, but that's not what I wanted. That's also not what I wanted. All right. Get these set. Then you're gonna go constraints, midpoint, click the line, and then click the edge, or click the points. You have 4 points, 4 lines. And then go back to the dimensions. And go ahead and put them in. Six. And then go back to draw, line, and then just connect them. All right, and then once you have that, go ahead and delete all the lines that are inside. All right, and now you're just left with the outline, the wind tunnel. Go to modeling, concepts, surfaces from sketch, lie, and generate. And now you have the wind tunnel. And so once you have that, you're going to go ahead and create the mesh. I don't know why I was doing that, but hopefully it's opening now. All right, now the mesh is open. This is the side model. Oh, you can close out that now. You don't need it. All right, now we're in the mesh. Let's go ahead and generate. And then go insert method, triangles, generate. And then for element size, I did 10. It's fine enough for what you need to do. And then when you have the airfoil, you can kind of increase the sizing for the size and everything. That reminds me, we also have to name everything. So inlet, outlets, and then control click all the different walls and just name them wall. It doesn't really matter. And then just go ahead and make sure everything looks good, which it does. Mesh is done. So go back here and go update. I don't know why it doesn't update itself, but it doesn't. Now we can go ahead and exit out. Open up setup. I'm going to do 4 processors. Low precision, as always, and go ahead and start it up. All right, now once it is all loaded in, models, I just do K epsilon with enhanced wall treatment, pressure gradient effects. Okay. And then go ahead, make sure it's air, which it is. Go to boundary conditions. Make sure that's a wall, pressure outlet's fine. And then for the video, Professor Osbey wants us to do the 10 meters a second condition, so just velocity magnitude 10. And go ahead and apply it. And then go to reference values, compute from inlet, reference to the surface body, and that is looking good. Methods, simple, compress it, that's fine. And then everything else, I believe, is fine. You can go ahead and just initialize now. Run your calculation. I do 150. That seems to be enough, and it runs quick enough. All right, and then what do you need to first get? So first is the contours. For that, I just do it straight in Fluent. It's just easier than doing it in post. Go to graphics, contours, select it all, and go ahead and compute, save display, and that is your pressure contour. You can go ahead and take a picture of that. You also want to do your total and dynamic pressure. That's why I like to do it in Fluent, because you don't have to do any formulas or anything. It's all right here. If you did it in post, you'd have to do a lot more work. So then this is the total pressure compute. And then as you see, this is the total pressure. And then you can go ahead and do dynamic pressure, compute. Shows all that there. And then velocity. Velocity magnitude is fine, compute. and it shows it there. So that's the first part of it. You screenshot them, put them in. And then for the next one, I do it in both Post and Fluent. I just find it easier to do the velocity and pressure in Post, and then the total and dynamic pressure in Fluent. But so once we get here, and Zoom is in my way, you'll just add a line, call it center line. And then the reason why I like to start from the origin is you already know your 0.1 is 0, and your 0.2 will just be the entire length of the wind tunnel, which, if I do that math quickly, is 3.996, and then just apply. Looks good. Now you'll go ahead and go to no, you go to chart, and then call it chart. I like making two different ones for velocity and pressure, just so I can, as I go through the different simulations, it updates them. But for this, it doesn't really matter. Location, center line. X-axis will be X. Y-axis, we'll do pressure first. All right. Oh no. All right. I don't really know what's happening. Maybe something with that. Let's just redo it. Go to X. Okay, there you go. I don't know why I was doing that. I named it chart. Fluent's stupid like that, but here we go. This is the pressure along the center line. Starts at 0, goes to 3.9 whatever. It was when you get this, you can just export as a CSV. And once you have the 3 different ones, you can go ahead and put it in. I did it in Google Docs because I like Google Docs more, but you can do it in Excel as well. And then you put it in for the 10 or the 5, 10, and 15 case, and you just make a graph of all 3 of them. Do the same for velocity as well. Define velocity, you just change the y-axis to velocity. Apply. And they should be like fairly inverse of each other, which makes sense, as you can see here, in terms of the shape of the graph. And so once you get those, you can go ahead, head back into Fluent, do an XY plot, and then new surface, line/rake, 0, 0, and then this will be, I lost it. I'm just going to re-add it up. Six, create, y0, yep. Oh, Doesn't really matter which one you use. But the reason why I like this is because you go back into Fluent and you can get total and dynamic pressure straight from Fluent, just the plot of them. And so this total pressure, you're gonna go write the file and write, save it, and then I find that it has the X values all jumbled up when you export it. So I sorted them from 0 to 3, whatever, and then I graphed it. This is my total pressure, and then you do the same for dynamic pressure. Hit plot, has that shape, same thing, write the plot file, hit write for all your cases, sort them, and you can go back and you have pressure or dynamic pressure. And so that's how you have it for all three of them, put them on the same graph. What is next? Then you have to do the vertical distribution. For that, I go back into post, just because I find it easier to do velocity and pressure in post. Even though you can't do total like special type of pressure, or you can, it's just a lot more work. But I'm gonna do line again. I'm gonna do not center line, tunnel line, I guess. Again, doesn't really matter. For this one, it's gonna be in the middle of the test section. So that's just in you'll just divide, if you started from the origin, you'll just divide the test section and add the first length. If you had your midpoint in the origin, you just have your x's at 0. So it's a bit easier from the middle, I guess, but doesn't really matter too much. Just basic math. Let's form one. And then go ahead and divide the vertical length of the test section in half. 6. And then apply. And as you see, this is not crosshair of a sniper. It is the center of the test section, not of the wind tunnel itself. And make a new graph. So doesn't really matter. Location will be tunnel line. And I like doing the y-axis as y and your x-axis as whatever you're doing. So for instance, we'll do velocity first, apply, and this is the vertical distribution, the velocity at that point. You do the same for pressure. Pressure, it's kind of whack. I don't fully know why, but then for some reason in Excel, you can't, or Google Docs and Excel, you can't rotate the graph 90 degrees. You can't have multiple series running along a vertical way, only a horizontal way. So they are turned 90 degrees from the vertical profile, but Professor Osprey said it's fine. And so you just, again, throw them all onto the Excel sheet or Google Docs or sheet, and then graph it. So that's velocity, that's pressure, that's total pressure. That's pressure. And to get total pressure for this part, you do have to go back into Fluent. Just open this up because I'm gonna need the coordinates for later. You're going to open up, create new line. Let's just name this one mid. Create. So get the X from here. Can I copy them? All right. X are the same. Yes, looks good. So you don't need dynamic pressure for this one. You just need total pressure. Not line 4. Say plot, and you get total pressure. Same thing as the other situations where you click write to file, write, export it, then sort it from least to greatest, and then you will have the distribution, and you just put it in each one, plot it, and that is all you gotta do for that part. And then for the airfoil, design modeler, you download the one that Dr. Osbe gave us. And then XY plane. Where is it? Create. Then you're gonna go ahead, select it, make sure it's in millimeters. Generate. There's your tiny airfoil. And then if you scroll in, you see that it is not connected there. So you can go ahead and do lines from point create one there, apply, and generate. And now you see it's connected. So once you have that, you're gonna have to remake your wind tunnel. So go XY plane, create sketch. For this one, I did make it the midline, the middle of the wind tunnel, just because I don't feel like moving the airfoil. So dimensions. constraints, click, nope, midpoint, click, click. And then you're gonna go ahead and do the same thing as before. Zoom out. I don't know why it does that sometimes. And then go dimensions. I'm sure there's a way you can like import it if you did it in the midpoint before, but it doesn't take too long to remake it, so I didn't bother trying to understand it. And then draw. And delete everything inside. Then you have the airfoil, you have the sketch. And so if I remember this correctly, you do concepts, surfaces from edges. Click these two. All right. Apply. And then create or generate. Now you have the surface for the airfoil. And then you do concept surfaces from sketches, apply, and then generate. And I have the two. So now what you have to do is go to create Boolean, subtract, and I believe first it's that one, and then it's this one. We're gonna find out. Yeah, that looks right. Yeah, that looks right now. And then go ahead and go to, I can close and all this stuff. All right, now you can go ahead and open up mesh. Go ahead and generate. And then, you need to name everything. Oh, yeah. All right, so name everything again. Inlet, outlets, wall, and then zoom on in. Name it. Wait. I think you have to do that one. Airfoil. All right. Make sure everything looks good. All right, so go back to mesh. Insert method triangles, and then generate. And then go ahead and do an inflation. Yeah, we can start with the inflation, actually, it's fine. Inflation, and then of the airfoil. All right, go back then. Smooth transition, I do 5 layers, and then generate. Well, I guess this airfoil needs to be the back one. All right, so then go to sizing. Inlet and outlets. Element size, I believe I did 10 millimeters. Oops. That looks fine. And then you do another sizing on the airfoil. And then this one I did 1 millimeter. All right. All right, so that looks good. This one, we can also tone it down a bit. It doesn't have to be as large, but we can do like 20, I guess, would be fine. Yeah, looks good. We can get out design modeler, update, and head over to setup. Same thing, double precision for start. Cool. Same thing as last time. K-epsilon, enhanced wall treatment, pressure gradient, and then I'll just stick with the 10 millimeter or 10 meters per second. Case, put 10, apply, close. And then go ahead to reference values, compute from inlet, surface body, methods, simple, resto. Then go ahead and initialize. Then for calculations, same thing, 150 and calculate. So then once you have that, you can go in the post, which is what I did for my project, but I'm just going to do it here because it takes less time and it's simpler. Go to everything, and then static pressure is fine, compute. And Professor Osway wants you to zoom in. I don't know why it's doing that, but, and see the pressure contour. I did it in, maybe that's the reason why, I don't know. I did it in post because it doesn't have like all the mesh triangles. It just has like a fluid thing, which I like, but that's your pressure. Then you go to velocity, save and display. Same thing, take a picture of that, or screenshot it, put it in, and then with those, you also have to get the drag and lift coefficient. For that, you'll go to reports, forces, and then go to air, select airfoil, not wall. And this you will use to get your pressure coefficient. To get your pressure coefficient, you're going to want to use the velocity at the entrance of the wind tunnel, not the inlet. So for that, I went to my center velocity of my previous case, and I interpolated between these 2 points to get it at 0, which would be in the middle of the entrance. And then I just did an Excel sheet and calculated it. And so, where is it? We can close out this. And so that's going to be for your drag force, or that is your drag force, and you're going to use it to find your drag coefficient. And to find your lift force, you just switch X and Y, make X0, Y1, print, and this is your lift force, and you'll use that in the same equation to find your lift coefficient, and you just do it for all those. And then I believe that is all. Looks like that's it. So yeah, that's everything for the final project.